Hey there, ladies and gentlemen, JD here with Timber and Anvil. I'm going to do an actual video instead of just a short. I got a couple pieces of steel here. This is a little piece of 1/4 inch round and 1/2 inch round. I already upset this and forged a scarf on it. And then I just forged a scarf on this so that they pretty much match in cross section. They would blend pretty well. As an example, if I were to forge this out into a tong. So I'm going to demonstrate forge welding it, a drop tong style weld in the induction forge. Looks like it's stuck. Throw some flux on there, do another heat, and try to blend that a little bit better. That wasn't so bad, I didn't even have to drop the tongs. Probably better off holding this in. Now that it's stuck. That's a good weld. We'll do another heat. Actually, let's crush it first. Now we'll flux it. Get another heat. Beautiful thing with induction forges, and there's a lot of beautiful things with induction forges, is that you can see there aren't any hot spots on the steel. It is uniformly heating all the way around. It's right now applying 807 amps of current all the way around uniformly. And right when I start seeing sparks, which is pretty dang close to now, that's a beautiful weld. I think I'll blend the scarf on the thick end. I don't know what you guys can see here. The scarf on the thick end needs to be blended just a little bit more, but otherwise that's an absolutely gorgeous weld. Get that with flux. Actually, I'm probably going to use a small cross beam. That'll allow me to really focus the pressure on that scarf, which I otherwise couldn't do with my rounding hammer. Another nice thing with induction forges is in a propane forge, the flux will destroy the liner of your forge, the refractory coating. Well, the flux is going to hit these copper coils, and they're kept cold by the chiller unit, so it's not going to do anything. It's just going to solidify. I like that a lot better. And brush. Absolutely beautiful. Let's see if turn the light on here and maybe you can see it a little bit better. Yeah, that should be a pretty clear shot. Come on, focus. I don't want to get my hand too close to that. That's a fantastic weld. Very happy with that. So Forge Welding and Induction Forge is basically cheating. It is so easy. You really can't miss because you are constantly looking at your piece. Your piece isn't buried in charcoal or coal, any solid fuel that's hiding it. And unlike propane, I mean, propane you can kind of see what's going on, but a critical point in forge welding is being able to see the sparks. Right when you start seeing sparks, is when the surfaces are at their melting point. You can't really see that in propane. With all the churning of gas and everything blowing around, I've never been able to see sparks in my propane forge. At least right now, I'm not 100% sure if it's capable of getting into a welding heat. I haven't really tried it. So there you have it. Demonstrated a very nice forge weld in here. Sorry I had to do a retake because my head was cut off. But anyhow, still, I can touch it, but still a little warm. Anywho, it goes to show how incredibly easy forge welding, forging in general is with an induction forge. I'm not selling these things, but I think I'd be a pretty good salesman for them because I think they're absolutely the bee's knees when it comes to blacksmithing. They're absolutely a game changer. This is US Solid is the brand, but they're all made in China by the same company. They're just rebranded. But anyhow, this is a 15 kilowatt version, and the 25 kilowatt version requires 480 volt three phase. So this is really the only one that everyday Joe can buy and use. You know, you can run this off of your electric stove power or whatever. This pulls 50 amps of current at 240 volts. And if you do the math, 50 times 240 equals 12,000 watts or 12 kilowatts of input power. And at 12 kilowatts, on my electric bill, my rate is 13 cents per kilowatt hour. And so that 12,000 watts means that every hour that I'm on this pedal right here is $1.56. That's nothing. $1.56 won't get me 2 pounds of propane. It'll get me maybe 2 pounds of coal, which I would burn up easily within about an hour, I'd say. And an hour in the coal forge is not an hour of forging. An hour in the coal forge, you know, heating it up for 5 minutes, I take it out, I'm working it for 2 or 3 minutes over the anvil, it's still burning coal. Same with propane, even worse with propane, because my coal forge is a hand crank blower. If I had a powered blower, I would be burning even more coal while I'm forging on the anvil. Propane, just as bad. As soon as I take my metal out of the forge, it is still burning the same rate. With induction forge, as soon as I'm done heating and I take my foot off the pedal, the only power it's drawing is the pump for the chiller unit and some fans inside here, which is negligible power consumption. So this is really not going to have any tangible impact on my electric bill. In fact, I've gotten an electric bill already since, and it's lower than the previous month's electric bill just because it's warmer out and so I don't need the furnace as much. So it's ludicrous. It's so cheap, so efficient. All of the thermal energy goes into your piece. In coal or propane, the thermal energy goes into air, and that air transfers it to your piece. This only heats your metal. It doesn't get more efficient than that. My friend who's kind of opposed to these things, he will argue that he could be way more productive in a propane forge because he could throw 7 pieces of steel in there, heat them all up, take one out, forge it. The other ones are still cooking away in there, developing really bad scale, getting decarb layers if it's a carburized, high carbon steel like a knife or something like that. He's still working this one on the anvil. He can throw it in there, grab another one. In a sense, he's right. You can get good throughput on a propane forge, more so than a coal forge. Coal forge was a way higher risk that you're going to burn up one of your pieces in there if you've got too many irons in the fire. With an induction forge, you don't have that because you really can't heat multiple pieces at once. But I'm not a production guy, and if I wanted to do production, if I wanted to make a whole bunch of S-hooks or something like that with my induction forge, I can do that. Because each heat, to get a forging temperature for something like this, I misspoke earlier, this is actually 5/8 and this is 5/16, it's not quarter and half. Same ratio, 50%, but anyhow. It only takes 10 to 15 seconds to get this 5/16 at a very good forging temperature. And so for me to grab one, and that's from room temperature, and I can do perfectly fine in a production style sense with this thing. So I don't think that's a downside at all. I think it's just my friend being stubborn. But like I said, forge welding is basically cheating in this thing. There we go. There's your forge weld. You can still see evidence of the weld, of course. If I heated it up more and forged it more and then brushed, and the scale would essentially eat that transition up and you wouldn't see it anyways. But in historical type work, this is perfectly acceptable. I have a spatula above my kitchen that I bought at an antique store in Michigan, and you can see all of the welds. There's about 7 on that thing because it was all wrought iron made from a bloomery, where you have this little bit of steel and you got to forge it into a little round shape and then flatten it out for a handle and then forge weld that onto another little bit because you need it a little bit longer. They didn't have, half-inch round bar that they could just go to the hardware store and buy like we can today. Things were a lot different back then. But you can see all of those forge welds exactly like these. Anyhow, I highly recommend an induction forge. What is this going to set you back? This is about $1,200, and the chiller unit, this is the 25-liter chiller unit. This is like $380. So you're looking at about $1,600 plus, the ancillary stuff, coolant. So use coolant for a TIG chiller. I just bought, I think it's $30 a gallon because I bought 3 gallons today for $90 on Amazon. Anywho, coil, just use 5/16 copper coil that you can get at the hardware store. There's nuts that you can buy. Every coil that you make has to have a set of nuts to go with it. You can't swap the nuts from one coil to another because once they're on there and everything is flared, you can't take it apart. So the nuts I think are $8 or $9 for a set. So it's really not that, except for the initial $1,600, it's not that bad. So save up for one if you think it's a good fit for you. Real quick, thought I was done, but figured I'm already here editing the video, might as well show you guys this. Here's that spatula that I was talking about. So here's a forge weld, here's another forge weld, that's 2. There's another one, 3. Argue that that's a 4th one. There's another one, 5. Here's another one here, there, 6. And I think there's one back here at the little button, the 7th one there. And so, let's see, yeah, that would be another. So this thing is loaded with forge welds that are still very evident. It's not perfect, but this was still very acceptable work back in its day. Very nice details, like the raised center portion of the handle. The handle is very beautifully centered, very symmetrical. It's a totally functional piece, and it survived who knows how many years. And the welds are still visible. So if somebody tells you that that weld looks like crap and it's going to fail, don't believe them. That's it for my rant. Take care, guys. Thanks a lot for watching. Hope you subscribe to the channel. Hope you find what I'm doing interesting. There's a lot of videos to come because I got a lot of work to do around the farm. It's just that I've been working on cleaning things up to make my workshops presentable rather than showing you guys the step-by-step, because I think that's boring and probably wouldn't get much attention. So take it easy, and we'll catch you next time.